Okay, so let's have a look at the proofs on homework 11. Let's start with number 1, obviously. So, the first thing to notice about number 1 is that you can do a De Morgan's law to this. And what that will do is it will give you a conjunction. You're going to negate both sides of this, and then that's going to be a conjunction. And then you can simplify both sides of these. You're also going to want to do, so that's going to be De Morgan's law, line 1. And then you can do a couple of simplifications. Simp 4. You don't have to do it in this order, but you're going to want to do that eventually. Then another thing you're going to want to do is bicon to this one, because whenever you have a biconditional, you can't really do anything with it. It doesn't work. It doesn't play well with others. There's only one rule that applies to biconditional, and it is bicon. So you're going to do bicon to line 3. Now, this conclusion is obviously a conditional, so it's possible to do this as a conditional proof. You probably won't need to, though. What I suggest to you is that you think of this as a series of hypothetical syllogisms. The first one that you're going to want to create is obviously B then something. And then the last one is going to be something then E. And once you have that, you should set up a series of hypothetical syllogisms so that eventually you come out with this as the result. Well, where's the one that involves B? It's this one. So you want to, you've already simplified the negation of this down here somewhere, and you want to turn that, so let's say it's here, you want to turn that into a conditional whose antecedent is B. At the moment you're going to have to change the order, and then you're going to have to do, well, what rule is it? It's my favorite rule of equivalence that changes what will be the negation of a conjunction into a conditional. And you can turn this into a conditional by the same method. And then when you do bicon, you're going to have one of the conditionals that you end up with is going to be useful, because that's going to be the one that ends up with E. So there's going to be a whole bunch of rules of equivalence, and then followed by a slew of hypothetical syllogisms. And that one should be fairly straightforward. If you do it by assuming B and getting E, you can do that too. That's fine. You just probably won't need to. Alright, let's move on to question 2. Incidentally, I hope Tyler is happy with the resolution of this one. This one, I think the obvious method to do this is by reductio ad absurdum, because if you start by doing reductio ad absurdum, you're obviously going to assume the negation of what you want to prove. You want to prove U, so you assume not U. By assumption reductio ad absurdum. What that enables you to do, as I mentioned in class, is modus tollens with line 2, and also modus tollens with line 3. Then, as I also mentioned in class, when you do reductio ad absurdum, the last indented line, let's say down here, line off the bottom, let's scroll this up in a very low-tech way. Let's say we're down on line 20, it won't be that much. You're going to want to have a contradiction, so something and the negation of that something. Now this could be U and not U, but it probably won't be. It'll probably be more like P and not P, or Q and not Q, or R and not R. One suggestion to you is that you're going to want to do disjunctive syllogism involving this. So you're going to want to have the negation of either side of these. And as I said in class, the negation of, say, if P then R is equivalent by implication to P and not R. If you remember in class, I said that should be obvious, because this is saying that if P then R is false. because you're negating it. But we know there's only one circumstance where a conditional is false. That's when the antecedent is true and the consequent is false. So that's why these two are equivalent. The circumstances where not if P then R is true is when P is true and R not R is true. So if you can create this, you can turn it into this by implication. And notice that you already have P. And that's enough clues for that.